Compound interest is a very important concept that you will certainly come across in your day-to-day life if you haven't already as an adult. It is the idea that whenever you have money and it earns interest either in your favor because you put in a savings account and you're getting money back, or against you because you haven't paid your credit card bill yet and that's accumulating interest, that money turns into more money. Because every time the interest compounds, it adds on another 4%, 5%, 3%, 1% of that money, whatever it is. And 1 cent per every dollar being added up over time does add up, which is what we're about to discover. If it's compounded continuously, that means that it's constantly having value added, just at an exponential, always increasing rate. We use this both for money and for also modeling population growth problems later. If it's compounded n times per year, that means you put your money in a bank account and once every other month, that's when the interest compounds rather than continuously. Both of these have their own separate equations. For this first set of practice, you're not only going to have to be able to plug into the equations, but you're also going to have to identify based on the problem which equation you want. Now, because I just plugged this into a random problem generator, it's pretty explicitly going to say the money is compounded continuously, or the money is compounded 5 times per year, or whatever it is. So it's not requiring that complex of, trying to think outside the box. You really just have to actually read the problem. Alright, so what do all these different variables mean? Well, A stands for just amount. That's the ending amount of money that you have. So if it says how much money do you have after 15 years, it's asking for you to find that ending amount. P is the principal. That is how much money you started with. So how much money did you put into your bank account, or what was your original credit card debt? R is the rate, so the rate at which it earns interest. And you need to convert this to a decimal. So if, for example, they say a rate of 5%, you've got to convert that to 0.05. If you forget on how to convert percents to decimals, it's always just the percent divided by 100. That will always give you your decimal. T is the amount of time that passed that you're earning interest on, and N is the number of times a year it's compounded. Go ahead and pause this video and write all of this down very, very neatly. You will need it later. Alright, welcome back. Before I move on to actually showing you examples, I want to really emphasize you must define your variables first. I will send your work back to you and make you define your variables if you turn it into me without all this listed out. I'm about to show you what I mean, but this is your most important step, because after you do this, it's how well do you plug into a calculator and follow all our operations. I really care that you can look at a word problem and identify what's the important information in that problem and what does that information mean. That is the really good life skill. Alright, moving on to our first example. Which, when you're taking notes, I wouldn't write down this example verbatim, just write down the variables that we're defining. Talia invests $5,299 in a retirement account with a fixed annual interest rate of 4% compounded continuously. What will the balance be after 15 years? Now, first thing you need to do is identify which problem do I want to use. Well, it says very explicitly compounded continuously. That means we want this problem. And that's it. I want you to go ahead and pause this video and see if you can define for yourself what are the variables I have and what are their values, and which one do I need to keep as a variable. Alright, welcome back. We don't know A, because it asks what will the balance be after 15 years. That means we don't know the ending amount. I'm going to go ahead and just put a question mark as a placeholder to know that's what I'm going to actually have to still solve for. Do we know her starting amount, though? Absolutely. That is $5,299. Do we know the rate at which it earns interest? That is 4%, which if we convert to a decimal is 0.04. Do we know the amount of time that's passed? Yes, we do. It says, what will the balance be after 15 years? So that's the amount of time that has passed, 15 years. Now we actually plug into the equation. So I'm going to rewrite my equation, even though I do have it written on my notes, or I got written up there. I want to see where I'm exactly replacing stuff in my equation. Can I replace A? No, I cannot, so I go ahead and just write A. Can I replace P? Absolutely. That's my 5,299. So E just is, like we said, that's our special ratio. That's like 2.7 blah, 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 blah. That's on your calculator. We leave E as is. We do know our rate, 0.04, and we do know our time, that's 15. Now when you're simplifying this, I mean, you pretty much are essentially going in the order of PEMDAS, which means that you have to start off with exponents. So I've got to actually simplify my physical exponent before I start taking e to that power, but that is easy enough to do with my handy-dandy calculator. Let me actually get out my calculator. So we've got 0.04 times 15. So that gives me 0.6. And I'm going to write down my in-between steps. I want to see an obnoxious amount of work shown for these problems because I'm not giving you that many of them. Alright, and then we can go ahead and take e to that power. We get our wonky forever going on decimal. 1.8221188. I'm just going to write down a whole bunch of decimal places just to make sure I keep it straight, especially if you get to a point where you're going to have to kind of save this number for later. You want to make sure a lot of decimals are written down. However, all we have to do next is multiply that by my starting amount. And I get that my ending amount is, oh, I messed up multiplying that by my starting amount. I know that because it should be in thousands. So 1.822118 times 5,299. I think I put a decimal in there. Yep, there we go. That's 9,655.40. And since doesn't intend to go past 2 decimal places, you can just stop there. Use that real world context. Like I said, you can always notice if you kind of messed up yourself, because I know 5,000 times 1 point something's got to be bigger than 5,000. So the fact that my decimal was off the first time told me I entered it in the calculator wrong. Alright, now you've got to put it back into the context of the problem. So let's look back at the problem. What were we actually trying to find out, which pretty much the last sentence of the problem consistently tells you. What will the balance be after 15 years? So use the wording of the problem. Just take off the word what will, move will here. The balance will be $9,655.40 after 15 years. Just like that. So we put it back into the context of the problem by basically flipping around the last sentence. Last sentence pretty much tells you consistently in most math problems what exactly it is you're looking for. Use that to your advantage. Alright, if you want to pause the video and write this down, that's fine, or you could have been writing down as I was going. Alright, welcome back. Alright, for this next one, even before I read it out loud and start kind of giving my own interpretation, pause the video, read the problem, and see if you can define your variables. Alright, welcome back. So we have John invests $5,241 into a retirement account with a fixed annual interest rate of 4% compounded 2 times per year. What is the account balance after 14 years? So, just like I said before, the fact they tell you very explicitly 2 times per year tells you it's not compounded continuously, but it's compounded a certain number of times per year. Now we define our variables. Like I said, defining your variables like this is a required step on your homework. You must do it. Alright. Do we know my ending amount? No, we do not. So go ahead and put a question mark there. Do we know my starting amount? Absolutely. That's $5,241. Do I know my rate? Yep, that's 4% again. So again, you've got to remember, convert your rate to a decimal. Number of times per year, that's twice per year. Amount of time passed, 14 years. So now we plug this guy into the equation. That's A equals P, 1 plus R over N to the NT. I know you got it written down on your notes too, but I still expect you to rewrite it again so that I know that you know exactly which equation we are using. And then you can see how I'm just replacing one variable at a time. A, can't replace it. That stays my variable. P, that's 5,241. 1 just is the number 1 always. Plus 0.04 divided by 2 to the 2 times 14. Now we start simplifying this one step at a time. I'm not going to touch my first number yet because, again, I'm basically following the order of PEMDAS. I've got to deal with my parenthesis first, then my exponent, then my multiplication. So in my parenthesis, within that, I got to do my division before I do my addition. So let's go ahead and do that. So we're going to do 0.04 divided by 2. .04 divided by 2 gives me 0.02, which perhaps you could do in your head, but there's no shame in using a calculator. 2 times 14, that's going to give me 28. I'm going to go ahead and just write that down just because I'll be using it later. If you want to do that separate step, that's fine. So then the amount is 5,241 times, really you should be able to add 1 to this in your head, but if you can't, I promise you it's 1.02 to the 28. And so now in order to take that to the 28th power, you're going to go ahead and press this button, then press 28 equals. So the amount is 5,241. That's the XY button on your calculator if you can't see that very well, where it's like X to the Y power. So that way you can go ahead and that X is just that 1.102 or whatever you first type into your calculator, and then the Y is the second one. Also, if you want to use Desmos, I'll link that again on this assignment. That's a really good scientific calculator for you to use on this, and it is also a free app on your phone if you want to do that. 1.7410242. Just write a whole bunch of decimals. Just be obnoxious. You don't need all of them, but do 5 or 6 times 5,241 equals. So my ending amount is 9,124.7. That 0 rounds up because that's 7 by it, 1. So now we've got to put it back into the context of the problem, which again, flip around the last sentence. Go ahead and pause the video and see if you can make a sentence about the problem on your own. Welcome back. That is the account balance will be $9,124.71 after 14 years. Which, if you want to take a step back from the problem and just appreciate that, John invested $5,000, did absolutely nothing, and then 14 years later had almost doubled his amount. That's pretty cool. That's why you save and invest, because money makes money without you even doing anything. Alright, go ahead and pause the video and make sure you got all these notes written down. Alright, welcome back. The last thing we're going to do is show that if you can also problem solve sort of backwards. So let's read this problem to see what I mean about that. Lawrence invests a sum of money in a savings account with a fixed annual interest rate of 7% compounded 3 times per year. After 20 years, the balance reaches $6,983.37. What was the amount of the initial investment? So a problem like this is, let's say you had a savings goal and you wanted to for sure have, $100,000 in 40 years. You could take this problem and figure out, well, how can I invest just a little bit of money now to have $100,000 in 40 years? I know 40 years seems like a long ways off, but it's never too early to start thinking about your future. Now first, now that that's aside, we got to figure out which problem do I want. Well, it says compounded 3 times per year. So I don't want compounded continuously. I want compounded n times per year. And now I've got to list out what variables do I know and not know. So I'm just going to go ahead and list out all of my variables. So do I know the ending amount? Yes, I do. This time it says this is my ending amount. So if it says after 20 years that's an ending amount. So then my ending amount is $6,983.37. My starting amount, I don't know that. That's where I'm going to put my question mark. My interest rate is 7%, which as a decimal is 0.07. Number of times per year is 3. And the amount of time passed is 20. So now we're going to go ahead and rewrite my equation. Then plug my known information into the equation. And like I said, I expect you to show your work like I'm showing your work. Don't just give me some numbers slapped on a piece of paper without any meaning behind them. So we're going to have to leave p because we don't know that. 1 plus 0.07 divided by 3 to the 3 times 20 power. Now we're going to go ahead and simplify my exponent down. Then take this and divide it by that answer. So let's go ahead and do that. So we're going to take 0.07, divide it by 3. I get 0.22 blah blah blah. And then we're going to go ahead and add 1 to that, even though really you should be able to add 1 to that in your head. So I get 6,983.37 equals unknown starting amount times 1.0233, repeating for infinity, to the 3 times 20 is 60th power. So let's go ahead and take this to the 60th power. So 6,983.37 equals P times 3.9904993596. I'm writing down an obnoxious amount of decimals because I'm about to lose this being saved in the memory of my calculator. So now I'm going to take 6,983.37 divided by 3.9904993596. This is just to reduce my error. So my starting principal was $1,749.9999, which really, if you were to round that, it's basically calculator error saying $1,750. So if you're doing this and you notice I've got like a 0.9999 because I had to kind of race it being lost in my calculator, and you're like literally $1 off, you still did the problem right. That's just calculator error. Equals P. So let's go ahead and put that back into the context of my problem. So let's look at our last sentence to give me my new sentence. What was the amount of the initial investment? Take off what was, move your verb of the initial investment was to the end. So the amount of the initial investment was $1,750. And there you go. If you haven't already written this down, pause, go ahead and write this down now. Alright, welcome back. One last example we're doing together. I know this is a long video, but word problems are tricky, so I want to make a long video. I'm going to try to be fancy, maybe in the comments and link it or something. I don't know yet. Software I'm using doesn't really let me edit. Or maybe I'm just an old lady who doesn't know how to edit. We'll see. Okay, next one. Anais invests some initial amount of money in a mutual fund set to grow 5% continuously. She wants to have $50,000 in 40 years. How much should she invest? Could be a real life situation. Alright, go ahead and pause this video, and I want you to see if you can do this problem entirely on your own, and then I will show you the solution. Alright, welcome back. First keyword, continuously, tells me I'm using my exponential growth equation. If you accidentally picked the other one, you would have run into the problem quickly. It doesn't tell me how many times per year. So let's go ahead and write down my variables. Alright. Do I know my ending amount? Yep, that's supposed to be $50,000. I want $50,000. I don't know how much I need to invest to do so. I know I'm going to have it growing 5% continuously. And I know I'm going to invest it for 40 years. So let's go ahead and plug this information in. First we rewrite. And now we plug in 50,000 equals my starting amount taken to the 0.05 times 40. So let's go ahead and plug all this information into my calculator. So I do 0.05 times 40. That just gives me 2. Nice and easy. Equals P e to the second power. So let's go ahead and take e to the second power. Which also, if you kind of think about this logically, this means that I'm taking my starting amount and essentially multiplying it by over 7. So I get over 7 times the amount of money if I invest it for 40 years, which is a significant return on your investment. Most people would be pretty jelly of that. Alright, now we're going to go ahead and take 50,000 divided by 7.3890561. I just sort of wrote down as many decimals as I could fit on the page. So you just need to invest $6,766.76 to do so. That's a great return on your investment. So you can over 7 times your investment by just investing it for a long amount of time. So how much should she invest? She should invest $6,766.76. Go ahead and take a picture of this and save it on your phone if you need, or just write down a separate sheet of paper. Alright, I'm going to go ahead and post this. Good luck. Please reach out if you have questions. But do watch this video. I know it's long, but do watch it.